Now, here's the best part. Not only did we successfully just integrate artificial intelligence into our software, but we are also storing the relevant data, such as the user prompt and the user output. And we're storing it here in the UID, AI answers in an array, prompts in an array. Let's learn how we can use artificial intelligence to code out Python-based functions that leverages OpenAI's API. Welcome back to the series where I'm showing you how to actually build out a backend. And in today's episode, we are checking out functions, OpenAI actions, this little yellow box. Therefore, up to this point, we've already set up our Firestore database. We've learned what a database is. We've learned how to leverage databases, and we've learned how to connect them in our Cursor AI app. Does that sound good? Bye-bye. I'll make sure I'll link the playlist down below. As you already know, or maybe you don't, maybe it's your first video with me. My name is Corbin. I'll be providing all the code at the end of this playlist in a nice little Git repo that you can just copy all the code. In addition, there's a little playlist dedicated to this. This is lesson 5. I'm showing you from 0 lines of code, absolute scratch, absolute nada, how to actually code out a backend and how to actually code out an app, leaning on artificial intelligence, because in theory, this playlist could have existed 10 years ago, but that's boring. I don't like that. Let's actually code with AI and let AI do all the heavy lifting. Therefore, in today's video, we're going to be going over functions and specifically setting up a function leveraging OpenAI's API. Now, what you're about to learn in today's video can apply to any type of function. For example, this isn't just OpenAI's API. This could be Claude's API. This could be you connecting to Gmail's API, connecting to Outlook's API. Whatever it may be, you're going to learn best practices here when it comes to setting up Python functions for an application. And if you don't even know what a Python function is, put it this way. When a user signs up for your software, this is what's going to provide the value. As the front end just makes stuff look pretty, but the back end actually provides the thing that's going to make you money. Okay, let's jump in. Here we go. We are in our project here that we set up in the last 5 lessons here. We're going to have to set up a new folder here in our functions. This is going to be a purely Python-based folder to handle this kind of workload. Now, before we do that, though, let's go ahead and set up a couple things. First off, navigate to your directory or where you've been building out this application. For me, it's actual backend app. Do npm start. Let's go ahead and have the front end load. E.g., this is the front end. We're in localhost 3000. We're going to go there. Now, let's create a new terminal window here where we're going to set up the backend or Firestore emulator. This is our fake pseudo backend, kind of like localhost 3000. This is like localhost 4000. This allows us to do backend functions, but not actually have it in the cloud. But I shouldn't have to explain this, as we've already learned this. But I like repeating stuff, as that's how you learn, right? Repetition. So we got in our CD here. This is the actual application. Let's do Firebase emulator start. With that command in, we're going to launch our localhost 4000. Right now it's loading up, so we'll get this nice little message here saying nothing exists, but it does. Just wait. There we go. From here, this is where we set up all of our backend logic, and we can test in a bubble environment. We've already set this up. We learned how we set this up. Therefore, let's go ahead and set up our function today. Come in over to our JS functions folder here. This is where we created the specific function of onUserCreate to create a new authenticated user. To put this more simply, let's walk through an example. I'm in my local environment here. I hit let's get started, sign in with Google, add new account, auto-generate information, sign in with Google. It is not found. Now it's found. We're good. Just a little bit of latency there. We go to Firebase emulator. We come over here. We go to Firestore. You'll notice we got a new doc, users, UID, and then the information here. We get the user profile image that we learned how to set up in a previous tutorial, which is a random situation here, a coin flip. You're going to be a dog. You're going to be a cat. And then we got the user's email, allergy orange, and then come over here, allergy orange. Now, if you were wondering what that little error was where it says like, user doc was not found, that's because of the initialization of the underlying variables we're getting set on that first run. E.g., users collection didn't exist. But on that first run, we had to create it. Therefore, there was latency. So for example, if I were to run this again, we wouldn't run into that issue. Log out. Let's get started. Sign in with Google. Add new account. Auto-generate information. Sign in with Google. And there we go. Loaded in perfectly. So now that we're here and we're caught up to what we've done up to this point, let's deal with OpenAI's API. And for people that are binge watching this series right now, and they're like, Corbin, I already saw that. That was a previous lesson. I get it. But the end of this is going to be like 4 hours long. So some people are going to come in and out and maybe want a real quick reminder of what we did previously. Regardless, here we go. So we're going to our Firebase app here. We're going to go to functions. We need to set up a new function here. And the purpose of this function will be the API. So right now we have the onUserCreate. Looking nice. If I come over here, we're going to have to initialize a new folder. This will be Python based. Actually, before we do that, since we're in this branch called new user data and we're finished with this workflow, we should do the big commands here. So we're going to do git add just to clean up this branch, git commit -m, cleaned go, good to go, git push origin, and it's going to be the branch name again. And here we go. New user data. There we go. And then what we can do here is we're going to do check out main. We're going to do git branch again, so then git branch. And if you're like, why are you going so fast? Watch the other lessons. We already did this. Dash D, and this is going to delete the local branch we don't need anymore. There we go. If we come over to main here, we are going to go to our GitHub. In our GitHub, we're going to do compare and pull request. Create pull request, and this is everything we already did in the previous lesson. So we're going to do merge pull request, confirm merge, delete branch. Okay, we're merged with main. Main, as you know, is the branch we want to keep safe and don't want it to blow up. Therefore, we're going to do get pull origin main to grab the merged branch that we just did there. There we go. Looking good. Now let's go ahead and create a new branch. We're going to do get checkout dash B. And then the new branch name, since we are creating an OpenAI API-oriented function, we'll just say AI function. There we go. Good branch. All right, sweet. Now, before we actually initialize our underlying folder here, let's create some UI in the front end that's going to basically allow us to manipulate and do actions. So coming over here, we're going to do something very simple. As my purpose is just to connect the dots, and then you'll do the creative stuff, okay? So all I'm going to do in today's video is I'm going to create a little input box here that hits submit. We're going to put in a prompt that's going to feed back to our API. Then we're going to get a response and view it here as well. Therefore, connecting the dots between a front end and a back end and a full stack application. So let me go ahead and listen to some Swedish House Mafia. I'm going to create this little front end change. We'll keep going. And as a side note, if you're like, wait, I want to see you create this front end change, that's not the purpose of this series or this playlist. That is an entirely different playlist I have on this channel of let's build out a front end. We're trying to build out back end. Back end is all that matters right now. I'll see you soon. So we are back. I'll go ahead and give you a real quick update on all the user interface and what I basically established so far. The idea that I'm doing here is I'll put in a prompt like, hello, how are you? I will hit submit. And up to this point, it's going to store the data of the user's prompts, as you can see here. Specifically, this is going to store this within Firestore here to the specific user's UID here, and then an array of prompts. Hello, how are you? E.g., every single time I log in as Otter Olive, I will always see this. For example, log out. Coming back in as Otter Olive here, there we go. They show up again. So this isn't stored in the user's browser, rather actually stored in our backend in our Firestore database. So now that we have this and we have our nice little UI, let's walk a little bit through the code. This box right here, I'm importing into dashboard so I can just kind of edit the code in a separate file. Specifically user prompts, and if we scroll down here, you will see that it's imported here. Therefore, the CSS oriented and the J6 oriented with this prompt box is found in userprompts.js and userprompts.css. To put simply, notice how this placeholder is what do you want to know? Had a bunch of S's right there. If I come back over, you will see them right here. Sometimes when developing front ends that work with back ends, you want to compartmentalize and refactor your code or refactor your code so that you can easily adjust changes to it. So for this example, I refactored the code so that it's basically the submission box and all the logic that will be associated with the submission box will be its own file. What I want you to take away from that is that when you are, especially in the beginning, very much so in the beginning, opt towards refactoring your code into very specific segments that you import into a bigger parent file. And the reason why is that, one, this helps with error mitigation, as now you are associating every sector of your software to a specific component. For example, the user prompts box here is its own separate component. Therefore, if I ever have an error in dashboard.js, I know it's not going to be associated with that specific component, but something else in the code. This keeps it clean, and especially if you plan on doing more advanced logic, this is just the go around and how you should proceed. This is all set up though. We have our front end looking good. Let's set up our back end. Real quick, you might be like, wait. How'd you store that into Firestore? We did a previous episode on this, but in this context, we're simply referencing the path again of users, UID, unique identifier, and then we're referencing prompts, which is going to be our array that we go ahead and use to reflect previous prompts that the user has inputted. With all that done though, let's begin. First off, I'm going to make a real quick commit to this current branch. So if we mess up, we can always roll back. Git add, git commit, -m, front and ready, git push origin, and then we will do the branch name, which in this context is AI function. And there we go. Now that we've done that, we have a clean branch ready to go. I'm going to go ahead and open up a new terminal window so we can start initializing the functions for Python. And before I do that, as a good rule of thumb here, remember Firebase log out, Firebase log in, because we're about to do some backend logic here. Therefore, we got to make sure we're logged in. Firebase log in, hit Y. Perfect. Once you're logged in, you'll see that message. This is the email that is associated with your Firebase project, which we set up earlier. Now let's go ahead and initialize our functions. Firebase init function, init functions, plural. So because of the fact that this is actually going to be creating a new function folder here that's Python based, we're going to do initialize. For the code base, just so there's clarity between the function folder and this new folder, I'm gonna do Python underscore functions. Hit enter. Subdirectory, we'll do the same thing, hit enter. For type of language, we're gonna do Python, obviously. And here we go. Do you want to install the dependencies? Yes. Let it download. Once that is complete, you'll come over here and guess what, y'all? We have successfully initialized our Python's functions folder. In today's video, all the logic that we'll do today will be in the main.py. In theory, though, when creating applications, each file should be associated with a very specific task. For example, maybe there is a task that is analyzing PDFs. Therefore, you call it analyzepdfs.py. In addition, big tip here, big tip coming. If you are creating a very complex application that will run a ton of Python functions, you're typically going to have a folder that's going to be a light Python function folder and then a regular Python function folder. And what I mean by this is that each function, when running it into a cloud server, will have its own amount of memory associated with it, whether it's 2 gigs, 4 gigs, 8 gigs. And what this means in your context is that the higher amount of memory associated with a function, the more expensive it will be at scale. To put simply, if the function you're running only requires around 1 gig of memory, you don't want to run that towards an 8 gig function. This is stuff we set up in our Google Cloud. This isn't necessarily absolutely needed when you're just starting application building. But put it this way, if you're 2 months down the road, or just save this segment of the video, or just write this down in your notes, keep in mind that associating memory with functions does have implications at scale. E.g., some functions will actually take 8 gigs of memory, some will only take 1. And then depending on how you want to set up your functions, that is very pertinent. So you don't spend extra money you don't need to run a 1 gigabyte memory type of function on an 8 gigabyte server. Don't worry if that didn't make that much sense, as all you need to know for now is how do we connect to OpenAI's API. So go to openai.com, go to their dashboard, and just simply hit start building. Once you're logged in, simply go to API keys. Make sure you have a credit card that is placed onto your account for billing. I believe they get free credits. I don't remember entirely. I made this account a year and 6 months ago. All I can say for certainty is that the longer you have an account and the more you spend towards an API endpoint, the more advantages you get within OpenAI's ecosystem. Hit API key. From here, simply hit create new secret key and then give it a name that is relevant and that you'll be able to recognize. I'm going to create a burner key today. And the reason why is just to show you how to do this. So permissions all, and then we're going to say create new secret key. Once I click this, go and copy it, save it, get ready to use it elsewhere in your project. Perfect. We have our key. This allows us to access artificial intelligence in our software application here. Now let's actually do it. Coming over to OpenAI's pricing page, let me just walk you through why you would choose a specific model in your context. I've done videos on this, like probably too many videos on this, so you can obviously search up my name, type in like prompting with API. This video, I'm not going to go too heavily into the actual prompting of how to structure a prompt, more in the sense of connecting it. If you want to see a video on that, I'll probably leave in the description down below / up there that shows you how to prompt with API. Here's the name of the game. When leveraging these endpoints, here are the models you're actually going to care about. The first one is GPT-4o Mini. This is a very attractive model because of the fact that what this model could do is be very cost effective at handling large amounts of data. We're talking about multiple pages in a PDF, like blocks of text. Use GPT-4o Mini. Very cost effective. GPT-4o is honestly in the same realm of being just as cost effective. What I suggest you to do is first opt for the Mini, see if that provides the value you want. If it works, then congratulations, you just got a very cost-effective solution. Now, if you're having issues and you're running into situations, opt for GPT-4o, see if it works in this realm. Yes, this is more expensive, but this is nowhere near the pricing that we saw a year and 6 months ago. For the amount of value you can provide an end user, this is still a great option. I mean, in the past, this used to be like $10, $15 for 1 million tokens. So then the next question is, okay, if those don't work for you, what's past that? That's going to come down to the O1 Mini and the O1 Preview. Now, only certain accounts have access to this yet. So if you have been using OpenAI's API for a while, you probably have access to it. But if you don't have access to it, don't worry. They roll this out pretty slowly, but everyone will get access to it. And who knows, by the time you're watching this video, they might have a new model called like O10 Preview. And I'm just like, what? Regardless, the same type of logic applies. There's going to be a lower base model that's very cost effective, very cheap for larger amounts of data. Then there's going to be these high level models that are more for complex outputs that require more input and more thought around it. When it comes to choosing between O1 Preview, O1 Mini, if you decide to use these models, opt for O1 Mini. It's more cost effective. In reality, O1 Preview is just overkill unless you really think that's going to apply to your application. So no overkill here, no roadkill. Opt for O1 Mini if you actually need to use it. These are very, very, very high level models here. I mean, this is extremely impressive stuff here. But I assume if you're watching this a year or 2 years from now, they've probably come out with a lot better. But regardless, Very, very cool stuff from OpenAI here. In today's video, though, we're going to be showcasing GPT-4o Mini, and the way you reference it in code is going to be right here. So GPT-4o Mini, nice. If you wanted to reference the other ones, just simply come up here, GPT-4o. Never really reference the ones with dates, as those are going to be deprecated models. For example, like 2 years from now, you'll never be able to access that endpoint, but probably this one, etc. Let's do it. We're back at it. I'm back. You're like, what just happened, Corbin? I got a bump up Slack message. It needed my attention, and I needed to address it. That's all done now. Different day. Let's do it. Wait, Corbin, I thought you were just a YouTuber. No. I run an entire software company, okay? Let's keep going here. So basically, the first thing I want to do to make sure that everything works good and we've installed this correctly is we're going to uncomment the code that we have here. Let's just prove that we can even deploy to our Firebase project with no hiccups. To do so, I'm going to simply select all this, Command/, and this is going to bring the code live here. Now, there's 2 ways we can test this. First way is we can deploy all the way to our project, or alternatively, let's just fire up the emulator and see if it's there. To fire up the emulator, we're going to make sure we're in a directory. We're going to say Firebase emulator start. We're going to hit enter here. Let's get running. Looking good so far. So we have initialized it, as you see right here on request example here. When it's green, that means it's good. So we have both functions. The first one we created in the previous tutorial for authentication, and this one, which is a HTTP callable, it looks like, in respect to Hello World, which is a very classic, it's a very nerdy thing. Nerds wear those on their shirt. I don't wear that. Also, if you can't tell, I'm sarcastic a lot of the times. That's just how I roll. But once we have that there, let's just go and deploy it to our Firebase app as well, so you can kind of see what it looks like in that context. To do that, we're going to just simply deploy our functions here. We're going to do Firebase deploy only functions, hit enter here, and then we should see an initialization of that new function here, and then just the redundance of the older function of a new user. There we go. As you'll notice here, it will skip it like I referenced in the earlier tutorial. It'll give you that little purple hue. And then you will see, since this is the first time we're creating this function, it's going to be updating here. And also notice it is a second gen function. This is number 2. Nummer 2. Post. For reference, it may stay there for a while. This typically happens when you initialize a function for the first time. So don't worry, it's not broken. There we go. Let it do its thing. So once we get that successful deployment here, we can come to our Firebase project. If I go over here to functions, we should see it. Boom. We have on request example here, and we have it as a V2. The reason we're doing this is I want to set a baseline. I want to basically prove to you that you can deploy a Python-based Firebase function so that everything past this in this tutorial, you won't be like, whoa, can I even deploy a function? Like, what's going on? Well, at least we confirm that you can deploy the example one. Therefore, now let's actually confirm the real one, which in this context is going to be an OpenAI API endpoint, which from what I remember of the purpose of this tutorial was we were going to put a prompt here and then get an answer here. We also are storing it in our Firebase database. Everything looks good. Let's proceed. So we don't really care about this example one. We can comment this out. I'm going to keep it there so when you guys can grab the code from me, you can just be like, I want to test this as well, as I will be putting this on a Git repo for free at the end of this series. Not yet. It's not over yet. Maybe it is by the time you're watching. It is November. It's almost Thanksgiving. Let's eat some good turkey. Therefore, let's open up a chat with Cursor AI here. We're going to hit Command L, Control L, and let's talk to our file here, which is going to be main.py. In theory, you can set up different files associated with different functions, which you'll probably do. But for now, let's create a good prompt here that we can use to get us on the right foot. This will be the prompt we start off with. Make sure in the main.py here, we're going to say, okay, great. Let's create a new function. Make it an HTTP callable, identifying the type of function here. I will send the payload of user prompt. From here, I want to do an OpenAI API completion, and then I provide example code from OpenAI's documentation. Here's the situation. I'm going to leave this in the description down below so you can reference it, as when you are calling certain API endpoints within OpenAI, they change it sometimes. So sometimes you'll get bad old code from AI because of the fact that it isn't up to date with the current documentation. So what I encourage you to do is go to the actual documentation. So in this context, it's create chat completion. If you are connecting other external APIs, same idea, just go to their documentation, find the most up-to-date code, and then just copy it and paste it into the chats. So at least it knows it's working on the right foot and you aren't getting a bunch of dead code. And when I say dead code, I'm referring to code that's old and deprecated. And just to clarify a little bit more what I mean by old and deprecated, basically as softwares keep improving and API endpoints keep going on, e.g. we get the O1 mini, O1 preview. The way OpenAI provides this as a API endpoint for software developers, sometimes they just change their documentation. Why do they do it? I don't know. I'm not part of OpenAI. They just do it. And so do other external API providers such as YouTube. I mean, they're on V3 right now. It used to be V1, so on. Regardless, we're going to keep going here. We're going to say, also, here's my API key. Just hard code it for now. Obviously, In production, don't push a hard-coded API key in the file. When I say hard-coded, I mean like actually putting the entire string of text right here. I'm going to show you how to put this in a secure way using a .env, which we've used earlier in this series. For now, though, what I like to do is in the early days when you're brand new to coding, or maybe you are good at coding and this is like a new idea for you, just hard code it. It gets one little error out of the way that you could possibly run into so you can understand at least your key works, and then obviously move it to a .env. And then for testing reasons, I went ahead and have it print out the console log, which you'll see pretty soon here. Therefore, let me show you the finished product here. But then there is like 3 or 4 steps you have to do or you're going to run into errors. So I'm here to help you. So we got to load it up in our emulator here. I'm actually going to go ahead and move this side by side so you can see this a lot better here. And you'll understand what I'm doing here. So basically, obviously, your emulator is going to be a little bubble for the backend functions we run. If you're like, what is all these messages? This looks like it's broken. Don't worry. That's just part of the game. So here's the situation. Basically, all I have it right now set up as is I put in a prompt here and I get an API response. Specifically, as you see above me, all we're doing is identifying that you are a helpful assistant. This is like the default messaging for OpenAI API. And then in addition to this, the actual prompt itself, the message that's going to be processed is just going to be what I put in. Now, in theory, this user prompt and how we can prompt API when it comes to creating software and creating value, check out this video right here. I'll make sure to leave in the description down below. I go full-blown, in-depth, my 5-step guide in how to create a good prompt for API. That sounded a little salesy. That sounded a little bit like top 5 things. But trust me, there's 5 steps to it. You can check out that video if you want to learn how to do prompting. I'm just here to show you how to connect the dots. So for example here, if I say, hello, what is the best way to eat a steak? And I hit submit. And with that question, we'll get a response right here. And sometimes you'll notice a function will be like beginning, finished, like really fast. Don't worry. Sometimes it'll false start like this. This just happens in the emulator. You won't be double charged. But from that question of how to make a perfect steak here, we got our 5-step guide from OpenAI talking about the quality of steak, cooking method, seasoning, temperature, and everything like, which we then can store into our database, everything by the board here. But let me show you how to get to this point. First things first, we need to make sure that our firebase.json is set effectively. So this should have already happened naturally when we did the Firebase init and initialized our directory of the Python functions folder. But if you don't see this, that's your first issue. You should see the Python functions, referencing our folder up here. So far, so good. Next, come to your firebase.js. Remember, this is where we're initializing everything for this application. Authentication, storage, Firestore, functions. Therefore, we need to identify that we are using a local function here, e.g. the call is coming from localhost 3000, localhost 4000. And the way we do this is obviously we're going to import our get functions, connect functions emulator, and then come down here is we need this very specific line here. We created this in the past tutorials for our auth, our Firestore, but now we also need it for a functions emulator. This makes it so when you send a message to your backend in this little bubble we have here, we're not going to get a CORS error where it's like, we don't recognize this. This must be false. No. There's no security issue here. We need to identify that it's okay if it comes from localhost 5001 as we are connecting this to specifically the context of our Firestore emulator. Now for you, you might be like, Corbin, how the heck do I even do this? I don't want to type it out. Well, one, you can either get the get in the description down below when it's available, or just Cursor AI, simply be like, we need the following, and then you would simply just put in like, you could even go layman and be like, get functions, HTTP callables, but in theory, just simply screenshot this video or talk to ChatGPT. You want connect Firestore emulator, and then we want the get functions as well. With both of these set up, and when we've already set this up in previous tutorials, this is going to get you through that second error you might run into, which is CORS. Firebase.js, connect functions emulator, make sure you're importing the get functions, connect functions emulator, and make sure you're exporting the get functions, which in this context is the functions, get functions app. Therefore, we're just going to export functions here. Round 2 done. Let me help you with what else you could run into. The next area you'll probably run into has to do with OpenAI and importing it. There's going to be a high probability here. It's going to say something along the lines of module not found, there's an issue, etc., etc. This can be very frustrating as you've installed it. It should be installed, but why the heck is this going on? Your error should look something similar to this, where we see no module named OpenAI. The issue here is that we need to install this within the venv of our Python functions folder. If that doesn't make that much sense, don't worry, just follow these commands. What's nice about this is that once it's installed, once it's done, you can move past this. These errors typically don't show up again once you get them done. So the first major thing you need to do is you need to go to specifically installing this to your Python functions folder, or whatever you called it. For me, I called it Python functions. For me, we're an actual backend app, which is our overall directory, but then we want to go one folder deeper, which is this folder right here, by simply doing /Python functions. I would save this to your cheat sheet, your little cheat sticky note, have this ready to go. Once you're in this, then we do source venv bin activate, and that's specifically this venv right here. To know whether you're in, you're going to see venv right here, you're going to see Python functions right here, and then the next one you want to do is pip install OpenAI. This is going to put it in our requirements.txt. Think of your requirements.txt as the dependencies we'll use in our function. What is a dependency? We'll be putting Stripe here. You could be putting YouTube here. You could be putting Google here. Like, this is just stuff of our ability to access external softwares, when we're building software. And OpenAI is obviously an external software. Once we do that, then we're going to do pip freeze requirements.txt. This is going to collect OpenAI and actually install it, as you see here. You should see all this, and then you'll be good to go. Now, let me go ahead and show you the next thing that you're probably going to have to do because of the fact that AI has not been updated as of recent when it comes to OpenAI's documentation and how to code in it. And what I'm referencing is that your AI may have gave you old code here of OpenAI.chat completion. This is no good. Lucky for us, they gave us a ways of going about solving this, but personally, the way I solved it was I simply just did pip install -- upgrade OpenAI, and this should bring you to the most up-to-date version of OpenAI. And then obviously, what you'll see in the code here is that there's a way we reference this now for chat completion. Chat completion basically is just our ability to put in a prompt, get an output that you saw earlier. So since we're already here and we're already in this venv in the Python functions, we might as well just do our last command here. This is going to allow us to access .env files, which is our security measure, which will make more sense. I'll show you what I mean, but just do this line. Pip install python -.env. Perfect. That's all done. This is a lot. I know this is a lot. Maybe for some of y'all, this is like light work and this is a walk in the park. But for some of y'all, especially if you're brand new to this, don't worry. This is a lot. That's the point. That's what we're learning, and that's why we use AI to learn more and more every single day. This is why there is an entire market segment that currently exists for no-code / hybrid ways of building out applications. But for some reason, you found yourself on this series and you're like, no. I'm coding it out raw. Okay. Let me help you do it. Therefore, that's why a lot of these series and a lot of these videos, at least in this series, I plan on doing a whole nother playlist where I actually build out a software with a value proposition and sell it. There's going to be a whole separate playlist for this. But this series specifically is just connecting the dots. Because once the dots are connected, you can really fill in the gaps of what you want to do for your specific software. With all that done, let's do our .env here. Let's explain this code, explain the front end code, how it all connects, and proceed. OpenAI API key os.getEnv OpenAI API key. This is where we store high-risk variables. In other words, we are grabbing the API key found in our .env here. So if I click this, open API key, it's named the exact same. This is where you're going to paste your API key you get from the OpenAI dashboard. Once you paste it there and you made sure you installed that previous dependency, this will work. And notice how we reference this key in our chat completion over here. All right, I'm going to actually paste my key here so it keeps working. So far, so good. And obviously, what I'm going to do is I'm going to always leave these little console logs here, such as OpenAI key is not set in the env file. I'm going to leave this in the code. So when you grab the code, you run into errors, you'll get clear ideas of where the errors are occurring. Scrolling down here, here is our current way of doing chat completions as of 2024 November. Client.chat.completions.create. The reason I say that and why I give a timestamp of the specific date is they may change this in the future, but you already know how to deal with that. Go to the documentation, see what the most recent one is, and then simply, grab this, Control L, Command L, and then simply give the updated code right there to Cursor AI, and then it'll give you the better way of doing this if they change it in the future. Regardless, I'm not going to go too much in depth on how to actually prompt for this. Here are some pointers. System. This is where you're going to give context of like, who are you? What do you do? How do you want structuring outputs? How do you want the AI to interact with the content coming in? And then the actual content itself, typically, this should just be data coming from the front end with very limited fixed text associated with it. When I say fixed text, I'm referring to stuff like you are a helpful assistant. No matter when we call this API endpoint, that will always show. There's no way this changes. Therefore, fixed text should rarely show up in the content. It should always be a variable that is found in the front end for a specific value you're looking for. Any type of directions or ways or structuring, outputs, inputs, everything should really be outlined in the content section here, as I referenced in that video earlier. So watch that if you want more depth of how to prompt, which I think is like I say it in 5 steps. We're good here though. This is solid. Right now, we have a fully functional backend. Let's look at our front end. So coming over to our front end, here is what you need to understand. First thing, Typically, when we are doing function calls to the backend, you will make this as its own separate component, which we kind of already did here. Sometimes you take this one step further where you have JS files that are just completely dedicated to that specific backend function because you're passing a ton of data in and out. In this example, this is kind of like a melding because of the fact that we do have a return here of some visual element, which for us is this right here. This is our visual element. Sometimes you have the JS file just purely be the function from the backend that we're calling and sending data to. In other times, it's okay to put the function directly within the front-end code as well. Basically, there can be a front-end element here with some type of calling of the backend. Sometimes there is just no return statement here, and it's purely just a backend code that we import and use within another component or JS file. All that will make more sense as you keep going here, but all you need to know from here is that when we call a function in our backend, we're always going to be importing get functions, HTTP callable, obviously if it's a callable in the sense of sending data, receiving data. Then we're going to always initialize with get functions here, and then we're going to get the specific name of our function that is found in the backend. So for us, it's generate completion. How do we know what the name is? Simply come back to your main.py here, def, generate completion. That's the name of it. If I said like generate apples, and I came over here, I would reference it as generate apples. So far, so good. And then what we do is that we're going to send data to this function. User prompt, input. The input's coming from the front end. Notice how we're passing the data as user prompt, and we're receiving the data here as user prompt. Finally, I have some dead code here when it comes to setting Firestore and everything about the board there. But so far, you have a pretty good idea of how to send data towards the backend and receive data back. So the last little step here that I want to do is I want to store the user's initial prompt, e.g. what I ask, and then I want to also store the output from OpenAI. As right now, I just have the output coming out as a console log. Like it shows up here. And that's what you should do as well. Don't over jump the gun here. Have it work in the sense of a console log that doesn't really show up anywhere other than the console. And then once you have it work there, proceed to this next step. Last two things on this topic before we do the last step of today's tutorial, which will be storing these values in our Firestore database. First thing, if you run into errors, you run into issues, and you spend hours on this video today trying to get this to work, completely understandable. Completely makes sense. That's just kind of how it is, especially if you're new to this. That's how you learn to code. The beginning is very much like you are hitting walls on walls on walls on walls. I can't tell you, when I first started coding, there would be times where I would have to solve one issue and it took me 2.5 days to do it. That's the point. But once you get through it, the next time is a lot easier as you know how to connect the dots better. All right, let's go and wrap this up. If you feel like you learned something so far, make sure to leave a like. It's completely free. Let's check it out. Let me go ahead and show you the finished product here, and then I'll walk you step by step how I did what I did. So obviously, we are in the authentication phase here, where we've created the Firestore database of a relevant user with their unique UID and then their profile stuff over here. In addition to this, we have successfully made it so we can contact an OpenAI API endpoint for AI value. So for example, if I ask, what is the capital of Texas, and I hit submit, we're hitting the OpenAI API endpoint, and then we get a response right there. Now here's the best part. Not only did we successfully just integrate artificial intelligence into our software, but we are also storing the relevant data, such as the user prompt and the user output, or the AI output. And we're storing it here in the UID, AI answers in an array, prompts in an array. Now to be absolutely transparent, if you want to do this at scale, don't store it like this. Store them as docs. Docs are going to allow it so that if the user has a ton of different questions, a ton of different outputs, it's a more scalable database. I'm just here to show you how to connect the dots. Regardless, let me show you how I did this. Right off the bat, if you're dealing with a lot of data and a lot of testing, I encourage you just to restart your emulator. Once you restart it, you're good to go. From here, let me show you what I did. First off, I went ahead and took out the functions logic out of the user prompts.js. I kept this just as a return element in the sense of just a front-end UI, which then I took the real logic and just put it in my dashboard.js. Just makes a little bit more sense due to the fact that if you come down here, when we do handle user prompt submit, this is where we're storing the underlying data of the user's prompt here with the user.ref. So we might as well just call the function as well, which is the generate completion function that we talked about earlier. One little side note, I went ahead and commented out the little randomized quote section. I'm going to leave this in the code though, so when you grab this code from the Git, you can go ahead and enable it if you want to see it. But for now, it's commented out. And to uncomment, you simply just command / and you'll get it back. And if you don't know what I'm talking about, I'm referencing this little box. Therefore, we just went ahead and combined the logic of saving the user's prompt in that specific doc path of array union on prompts. And on top of that, sent that user prompt's data to our backend using this logic right here. Therefore, when we store the AI output though, we're going to store that within our Python function. Quick side note, the reason I'm describing the code how I am right now is for you to talk to Cursor AI if you need to with the Command L and simply put in the words I'm using into those chats to really get the best kind of outputs. For example, the code right here when referencing the kind of path and how we want to store it. Or earlier when I was talking about a scalable database, making sure that this data is stored as a doc rather than an array. Coming over to our main.py here, everything will stay the same except for the fact that we will now add the ability to store this in our database. Therefore, from the import, we're going to also import Firestore as well. Firestore is the database in the paths. And then notice with the code I'm going to provide you with, I give you these little comments so you really understand what's occurring. Obviously, same situation here. We're going to reference the data path, users, unique UID. And then we are going to take the assistance message, which comes from that chat completion request, and we're going to store it in AI answers. Therefore, as you can see this emulator, AI answers the answer we got from OpenAI's API request. Here's the deal. When we access AI, like I showed you in today's tutorial, it's a little bit more nuanced in the sense of prompt structuring, prompt outputs. Like this is new stuff to software. A lot of the times when you connect external APIs, let's just say YouTube, for example, it's very much like input, output. For example, if we're referencing YouTube and maybe we want to download or upload a thumbnail from YouTube's API, it's very much so provide the video ID, get the video thumbnail. I say this to make clear that when accessing other external APIs, it's a lot simpler. The logic's a lot easier to understand. Artificial intelligence API endpoints, though, are a lot more nuanced, and that's partly probably the reason that you're watching this entire series to begin with, as this is a completely new market in software entirely. Our ability to prompt and get value through text is a big deal. And obviously, we can connect this API to other stuff OpenAI provides with, whether that is going to be higher level models, or alternatively, their Whisper API, DALL-E 3 API, everything like that. What I can say with confidence, though, is now you understand some troubleshoots and workarounds of issues you may run into and how to solve them. So if you feel like you learned something today, make sure to leave a like. The next video in this series will be storage, so I'll see you in that video. External API, OpenAI. 2 random videos. That's my face. I'll see you in the next video.